Okay, Assalamualaikum. Tajahau, Vanakkam. My name is White Fanafizi Muhammad. Today I will be sharing with you about our final presentation regarding our topic, which is design and development of electric scooter demonstration for our topic, for our subject BMA and BMM for 704 integrated design project. First of all, our team consists of four members, which are Muhammad Faris bin Nordin, Ahmad Shakir bin Abdul Aziz, and Muhammad Zunakim Rahman. Firstly, for the introduction, EV is called electric vehicle that uses one or more electric motor as their propulsion, and the vehicle usually use electricity from resources such as battery, solar panel, and cell. For our topic today, our scooter uses using the battery, which are using lead acid battery, and then we will go with the problem statement. Firstly, first thing first is what does the improvement design? Firstly, we want to have a more stable and firm design, and then we want a scooter that can be ride easily to reduce the human energy. And then next problem that we face, we want to focus on what does the important things. Firstly, we want an electric which are safe to be used and reduce it in cost, which are really affordable. And then thirdly, what are the real causes of climate exam, etc. So the problem, we want to find the suitable material to make the chassis, to design material. So we must find the vegetable barrier, which are uh, uh, low in weight but increase in its strength. Okay, then we will go with objective. So for the objective, our aim is to design a three-wheel electric scooter using a design approach by specific objective for the project. Firstly, we want to determine the most suitable material for making this chassis, to design and fabricate a highly custom three-wheel scooter, and then to test the electric scooter chassis functioning using brushless motor power. Okay. And then for the project scope, our design will be operated by using SolidWorks. And then for the finite element analysis, we done also in the SolidWorks. And then we will want to development of the electric scooter by using electric motor. Then we want to develop a three-wheel scooter below 300 kg of load to design a scooter analysis based on current market to precisely design a conceptual electric scooter. Okay, we will go with the concept selection. Firstly, the picture on the left shows the three-wheel scooter chassis that that you can find in the lab on FKP, using the scooter also using the battery as the source, electric scooter. And then on the right we can see also a picture of the electric scooter, which can be found in the internet or other page. We use their design, and we study their their parts and apa ni, or their parts and their pattern for our design. Okay, first thing first is our first concept generation design. This is our second generation design, and this is our third concept design. For the concept screening, basically we have done a concept screening based on few criteria. Basically, with the third concept is more suitable and more preferable because it has high durability compared to first and second concept. It has high of strength and high performance compared to the others. So by doing that, the conclusion we get a positive number. So we proceeding our design by using the conceptual design of object concept design as our permanent design. So here's our finalized selected design.
Okay, Assalamualaikum. My name is Muhammad Faris. Okay, next I will talk about finalized selected design. As Irfan said before, we choose our third concept as our design, selected design. So we make a 3D drawing of our electric scooter chassis by using SolidWorks 2017. So this is the isometric view for our chassis. Okay, next, this is the front view of our chassis. Then this is the side view, and this is top view. Okay. Then we go to the drawing of our chassis. Okay, this drawing. Okay. This drawing we use scale of 110, 120, 120. So this is the actual dimension for our chassis, which is in millimeter SI unit. Okay, as you can see, we use only pipe, which is the diameter of the pipe is 33.70 millimeter to make our chassis, and the length of the chassis is only 1446.43 millimeter. Okay, then we go to the design analysis. So our first analysis is one meter stress. As you can see on this figure, show that the stress analysis, the one meter stress analysis result the value of the product minimum is 10 megapascal, and the maximum is 1.470 to the power of 8 megapascal. The maximum stress occur at the back of the chassis, which is you can see in the red color at the back. So when this stress is happen when we apply 3000 Newton force on the body, on the chassis body. Okay, next. Then we go to the displacement our of this displacement plot for our chassis. On this figure, we can see the minimum value for the displacement is 1 to the power of -3 millimeter, and the maximum of the displacement is 2.086 millimeter. The maximum displacement occur at the middle of the body, which is you can see in red color, since we need to bring 2% at one time and the electrical equipment on the chassis. So we put the force value is 3000 Newton. Okay, next we go to the factor of safety. Okay, the factor of safety. The minimum value of the factor of safety is 2.392, and the maximum is 1 to the power of 16. The minimum factor of safety occur at the almost the whole of the chassis, which is red color, and the maximum factor of safety occur at the back of the fork holder, as you can see in the blue color. So the force applied on this body is 3000 Newton also.
Okay, Assalamualaikum. My name is Mohd bin Rahman. ID MH17035. Okay, after we select the design, then we proceed with the fabrication. Okay, first we select the steel, which is a hollow steel, and do a cutting process with a hand drill, and then we assembly the chassis by doing a welding process. So this is the welding process we doing. Okay. After after we finish the welding, we do a painting and we assemble all the parts. The next is we cut the steel and welding to make a frame structure for the chassis. After that, we choose the fiberglass to cover the structures. So this is the process to make a fiberglass to the structure, and this is our final product. And we do some testing on this product. So this is the overview of our product after we finish the fiberglass process. And we do some testing on the speed of the EV, how fast that it can be go. So we do some testing on how much speed that this EV can go. This electric scooter can go above than 20 km per hour. So this is our final product. That's all for me. Thank you.
Okay, my name is Muhammad Shakir bin Abdul Aziz. My metric number MH17032. Now I will proceed. Now I will proceed to engineering economy. Okay, 12.1 variable cost. We have about 15 material that we use in this electric vehicle. First material we use tire, battery. Third is brake wire. 4 is handbrake. 5 is starter switch. 6 is insulate wire connector. 7 is insulate wire connector also. 8 is wire for battery connection. 9 wire for motor connection. 10 mid steel hollow. 11 mid steel hollow also. 12 is about bolt and nut. 13 is plain steel flat bar. 14 is plate zinc. 15 is throttle. Okay, for battery we use lead acid battery. Then the total cost of this 50 material is about 1,198 ringgit and 80 cents. Okay, next is 12.2 feed cost. We have 4 equipment that has fixed cost. First is hand drill. It's about the cost of hand drill is about 200 ringgit. Second is hand angle grinder. The cost is about 80 ringgit. Third is a screwdriver. One set is about 25 ringgit. Fourth is measuring tape. Uh, cost one cost of it is about 5 ringgit. So the total cost of equipment is about 310 ringgit. Okay, next is a calculation for break-even. 12.3. Okay. Price to say is about 1,050 ringgit, 1,500 ringgit. Okay, now we calculate V, fixed cost, over price minus variable cost plus V. So we get about 1.03. Okay, now the total cost is equal to fixed cost plus variable cost. Okay, 310 ringgit plus 1,198 ringgit 80 cent, multiply 1. The total is 1,508 ringgit 80 cent. Price to sale is 1,500 ringgit. So total revenue is about 1,500 ringgit. Okay, we proceed to return of investment, ROI 12.3. Okay, the total sales is 1,500 ringgit. So the target profit is about 6,000 ringgit that we target. So you need to reach the target profit is target profit over price minus variable cost plus V, and then we get 20 unit for to reach the target profit. Okay, for core investment, for cost investment, fixed cost plus variable cost plus number of unit. Okay, for fixed cost is about 310 ringgit, and we plus with variable cost. Variable cost it is 1,198 ringgit 80 cent, multiply with 21 unit, and then we get 25,484 ringgit 80 cent. That is total for cost of investment. Then gain on investment. To get this total, we must calculate the number of unit price multiply with price. Okay, number of unit price is 21 multiply with 1,500 ringgit, then the total is 31,500 ringgit for gain of investment. So ROI is equal gain minus cost over cost. Okay, gain we get 31,500 ringgit. We minus with the cost is 25,484 ringgit 80 cents over the cost is 25,484 80 cents ringgit. Then we get 0.236. So in percentage ROI, this ROI we get 23.6%. Okay, next is engineering maintenance. Okay, now is preventive maintenance 13.1. There is a lot of preventive maintenance that we can perform in order to increase the productivity of our product and to avoid failure. Okay, first you must check constantly and service the electric scooter. The tire, battery drain, and check brake is recommended to check regularly for our own safety. Tire pressure is most important and should be around 37 until 37 APA unit for a light rider and 42 until 43 for heavier one. Okay, life expectancy of a battery is about 1000 charge. To keep it high level of battery charge, you need to leave it in minus temperature when it's full up, plug it and do not let the battery run out. Service the brake pad when the brake are not really working. It is important to ensure that The brakes are in the best condition. Okay, predictive maintenance. We are using the lead acid rechargeable battery, and we are required to repeat recycling from fully charged to fully discharged, and that may cause loss of active material from the positive plate. To avoid this occurrence of this problem, the battery will need to be replaced for every 5 years. And then wire. Wire should be read in clockwise around the screw terminal. If they are reversed, they can be prone to loosening. The wire nut connection, all the bare copper wires should be hidden under the plastic cap, with no exposed wire showing at the bottom of the wire nut. In order to fix the problem in the next year, we must disconnect the wire and add the clip of the excess wire or strip of additional insulation so the proper amount of wire is exposed. Then reconnect the wire to the screw terminal or wire nut. Thus, a proper maintenance of it should be done and make it last a bit longer. Okay, for conclusion, by the end of this project, we are able to achieve our objective. First, successfully design and fabricate the electric motor scooter with using appropriate material. Second, develop a comfortable and safe electric motor scooter. The objective of this project was successfully achieved. One concept design has been generated. Design also selected due to its advantage. This project helped us to understand more how the concept design selection method used. Also, this project helped understanding of anchor joint motion, structure and injury. This project teaches us how to apply all engineering concepts that we learned in the study. Lastly, the project follow the project planning. Okay, this is a flowchart for our project. Start from selecting the IDP title until the fabrication process and final presentation. Okay, this chart shows us the prepare the design and material until we do the assemble all the component needed, do the finishing parts, and lastly testing process of the electric vehicle. Okay, for Gantt chart, for this project, we need 1 month or 4 weeks to fabricate this electric vehicle. This our Gantt chart from 22 September 2020 until week 4, 16 October 2020, that we has finished and fabricate the electric vehicle completely. Okay, that's all from we. Thank you so much. That's all.